Our next presentation is by Earl Franks from New Mexico DOT.
Thank you all for sticking around for these last couple presentations. I'm going to present on the NMDOT District 1 Bridge Section Best Projects and Best Practices. Here's my presentation outline. Every bridge has a story, so guess what? I'm going to tell you a story about a bridge. NMDOT District 1 Bridge Section Background, NMDOT Bridge Preservation Specification sections, and then the bulk of the presentation will be District 1 Bridge Section Best Projects and Best Practices. Structure 6661, located on New Mexico 173 over the San Juan River below Navajo Lake Dam, was built in 1966 by New Mexico State Highway Department bridge construction crew led by Charlie Franks, who is my grandfather. He was a lifelong coal miner. He literally grew up in the coal mines in Colorado. His father died when he was a young kid, and the company's way to console the family, I guess, was to put the kids to work in the coal mine. So him and his older brother started working in the coal mine to make ends meet for the family. And he ended up working for Oscar Huber in Madrid, New Mexico as a mine foreman, and eventually owned his own mine in Cañoncito, New Mexico. But he was a contributor to World War II, producing coal for World War II. And when that dried up after World War II, he was looking for a retirement job. So he went to work for the Highway Department and on a crew that built bridges at the time. So the story for this structure, the project was a bridge replacement project funded by the U.S. Bureau of Public Roads, which eventually became Federal Highway Administration. The original river crossing on this highway failed during flooding, which initiated design of an upgraded crossing. The department made 2 attempts to let the project to contract, and both times bid prices far exceeded the engineering estimate, so the department decided to self-perform construction of the structure and approaches. The interstate boom likely influenced their decision to complete this project with 100% department forces. The design was changed from a 3-span pre-stressed concrete multi-girder to 4-span salvaged rolled steel multi-girder, which improved hydraulics upstream and made use of salvage girders in good condition. And that totally had my grandfather's name on it. You know, he brought up a family through the Depression, and he saved everything. The deck is a little over 6,000 square feet. The railing was changed from steel railing type A at $22.50 a foot to reinforced concrete bridge rail at $5 a foot. Work began in March 1966, and the project was substantially complete, as far as I can tell from the documentation that I looked through, in September 1966. And the Bureau of Reclamation stopped flow from the Navajo Lake Dam within 3 months of a request from the department to allow piles to be driven in the riverbed. That's like unheard of today. That kind of blows my mind. And the final project cost was $141,598.85, about $23.22 per square foot total project cost. That just shows you profile view of the original voided plan and then the as-built 4-span rolled steel girders plan. And this is a confer memo. Actually, when I started working for the department, we were still using these things. But it's just amazes me what the department holds on to. District 5 had an entire paper file of documentation on this project that I got my hands on, and that's where I got the information for this. My grandpa died when I was 6 years old, so I just more knew of him than knew him, you know. And in 2021, I was going up to visit my sister-in-law in Idaho and decided to stop by here with my family. So those 2 photos to the left are my kiddos. And the photo to the right kind of shows some of the preservation work that was done to that bridge since it was built. It has preformed foam joint seals. I understand there was some concrete repair work done to the bridge deck, and it has a polymer overlay. So my point of this slide was to show that, with adequate design and construction, and if, as a preservation practitioner, if we do our job properly, these structures should last for generations. I don't know that my grandfather ever thought that the great-grandkids he never knew would be fishing underneath that bridge, but that's what we did. And it's a cool project in that, it's 100% state forces did this. I kind of wish that we would do that more often. We recently let a project where we got a concrete structure repair unit cost of $4,000 a square yard. And I wanted our crew to go do that work because they can do it for a fraction of that, probably a quarter of that cost. But I was told to step down. Okay, I'll describe our section a little bit. The District 1 bridge section inventory currently has 785 structures out of 3,773 statewide. That includes 42 timber, 44 steel, 307 concrete, and a whole lot of culverts, 392. District 1 statewide transportation improvement program, bridge project allocations average just over, or around 30 million from 2018 to 2022, including about 4.5 million per year bridge preservation allocation average. The bridge project allocations average about 45% of the total allocation for that period. These projects are typically pre-qualified, low bid, and let to contract. We have a contract maintenance road betterment program. Those allocations have ranged from about $500,000 per year to over $2 million per year. Those are typically done through price agreements and job order contracting. Then we have our structure crew, who is over in that corner. They averaged about $850,000 per year total operating budget during the past 5 years, including a little over $300,000 per year average labor, almost $500,000 per year average equipment, and $63,000 per year average commodities. Procurement mechanisms for equipment purchase, rental equipment, and materials include price agreement, request for quotations for small purchases below $60,000 threshold in accordance with our procurement code. This graph kind of shows, I know Shane showed a similar graph, but this shows that we're kind of headed in the right direction, I think, ultimately. I came on board in District 1 in 1999, and I brought some bridge inspection experience to the table, and the bridge inspection program in District 1 was not too good, to say the least. So we started focusing on doing inspections according to the recording and coding guide, and doing inspections at the proper time of the year, which we have over 200 miles of the Rio Grande Valley, and it's a heavy agricultural area. So there's irrigation canals and river bridges that you ought to look at when it's not irrigation season, so you can get to where you need to get to look at it. And that wasn't happening. So that incline from 99 to 2004 had a lot to do with our bridge inspection program, and also it had a lot to do with interstate boom bridges coming to age all at the same time. But at the same time, we were implementing preservation finally. And we focused on bridge decks, concrete repair on bridge decks, joint seals, and getting the bridge deck sealed. Basically making a watertight roof over the bridge before we addressed anything below. There's a map of our district boundary. We're there in the lower left, the southwest portion of the state. These are Division 500 specification sections. The bulk of our bridge preservation work happens with these sections. Some of the stuff that we do more predominantly in District 1 are pier and bearing modifications, penetrating water repellent treatment, concrete structure repair, epoxy injection, crack sealing using low viscosity gravity fed sealers. And then the joints we typically use for larger movement joints are Section 562 strip seal with embedded steel extrusions, and then the preformed foam joints and preformed silicone coated foam joint systems for smaller movements. We also have, other items in different divisions that we use, such as this crew does a lot of erosion control work. That's our Section 602, like rock and wire installations. And we also have items such as injection of high-density polyurethane that we do not have specification sections for. We generally use special provision for that. So now this is a bulk of the presentation will be on our best programs. It's basically an employee recognition program where each year we submit projects or practices to be considered for recognition of a statewide award. Originally, I was going to try to cover all of these, but my presentation was way too long, so I'm going to focus on the highlighted bullet points, and those are more recent. This definitely isn't a comprehensive list. We've been fairly successful in being recognized for some of the good work that the bridge section employees do. First project is in 2018 statewide best project. It's structure 6802 collision repair. The structure is located on I-10 over an unnamed waterway. It was hit by a commercial motor vehicle traveling east, crossing the median on January 20th, 2018. The collision destroyed about 10 feet of Pier Cap 3 and broke Pier 3 Pile 9 below the ground. The Deming Maintenance Patrol immediately implemented traffic control in both directions of traffic, repaired the guardrail on the eastbound passing lane on January 22nd, and then our bridge inspection crew performed a damage inspection on January 22nd and recommended immediate installation of temporary shoring prior to design and construction of permanent repairs so that the westbound passing lane could be reopened to traffic. The District 1 structure repair crew mobilized from Williamsburg, New Mexico, and installed temporary shoring as directed by me on January 26th, allowing removal of the Interstate 1-lane closure on the next day. And then we designed permanent repair plans in-house, and the crew permanently repaired the damage using an Interstate 1-lane closure on the westbound passing lane from July 17th to August 16th of that year. The structure repair crew successfully completed the assignment with assistance from the Deming Maintenance Patrol within 30 calendar days scheduled for the project, and these repairs are still performing well. Some of the equipment we use, of course, traffic control devices. We have a XPS 60 shoring system that is another, I think, best practice within this. I'd recommend anybody in another state in my position that you have good shoring equipment like that. We have we used a large loader, skid steer loader, backhoe, water truck, vibratory plate compactor, compressor, generator, concrete repair equipment, dump trailer, concrete forming equipment, concrete finishing equipment, a 30-ton hydraulic bottle jack, welder, ready-mix concrete truck, and various hand tools. And the crew members are listed there. The project was about $110,431.91 per our maintenance management system data. That structure is a 4-span continuous reinforced concrete slab deck structure with reinforced concrete stub abutments and reinforced concrete pier caps on timber piles. Carries I-10. Major work items included traffic control, excavation, temporary shoring, backfill, forming, placement of approximately 4 cubic yards of self-consolidating concrete, installation of a steel pile splice assembly, epoxy injection, coating steel, and removal of structures and obstructions and concrete repair. There's some photos showing the damage and then the repair. And this is just slightly better than scribbling on the back of a napkin, but this is what I gave the crew to implement the temporary shoring plan. And that's what that pile looked like below ground. It was a fairly clean break. When we cut it off, the pile really looked like new. These are some photos showing the temporary shoring. That timber foundation is some more salvage materials that came off of a state standard timber bridge that we replaced. We use those quite a bit. And then that sheet to the left is actually a salvaged assembly that we took off another bridge, and the crew was able to use it on this bridge. There's some more photos of the collision repair. That's John Looker welding back there. He's sitting in the back of the audience. We preloaded this with that bottle jack and then mechanically fastened the assembly to the timber and then injected the annular space between the timber and the steel with epoxy, and then surrounded that with a reinforced concrete encasement. So that's showing that, and then we filled that assembly with concrete, and you can see the steel coming out of it to be incorporated into the pure cap concrete. Some of the formwork, finishing the concrete, that self-consolidating concrete came out pretty well. We had very little honeycombing. And that's showing the final project and them removing the shoring. So the next project in 2020, they were recognized for a statewide best project. The structure is 7394 concrete repair. So that structure is on New Mexico 498 over the Montoya Lateral. It was built in 1959. Has a single simple span with adjacent non-composite pre-stressed concrete box girders. The reinforced concrete abutments deteriorated from new condition in 1959 to poor condition in 2007 due to widespread delamination. The delamination was caused by a combination of low reinforcing steel cover and the fact that the abutments are exposed to extremely brackish water from the lateral. Project control number, prior to 2014, the structure was placed on the STIP to be replaced. Project control number E100-140 was established, and a reinforced concrete box culvert was designed to replace the structure, mainly to accommodate turnouts from the lateral owner. Due to various unforeseen conditions, the scope of work was changed from structure replacement to structure rehabilitation during construction phase. The contractor offered a concrete structure repair unit cost of $875 a square yard, but they could not remobilize to do that work before water was released from the river. Therefore, this crew over here, our structure repair crew, was tasked with completing the concrete repair. That's some of the equipment they used. This one, we used a concrete pump. There's the crew members. That project total cost was $135,990.98. Started on April 8th, 2019, and finished on June 13th, 2019. Some of the best practices within this project: structure rehabilitation versus replacement at a much lower overall project cost with similar expected material service life. We used cathodic protection on the reinforcing steel. We used re-emulsifiable bonding agent to improve bond between the existing substrate and the new concrete. We used form and pump placement operation as the best option to maintain consistency and quality of the concrete structure repair, considering the tight workspace, limited access, and magnitude of repair area. The use of 100% silane, our Section 532, in conjunction with the use of thicker epoxy concrete sealer, Section 535, to prevent water infiltration from the Montoya lateral. This is a guide from ACI. It's ACI Wrap Bulletin 5. We use that as some guidance because our specifications don't necessarily cover forming and pumping. And here's some photos of that repair. You can see how widespread it is. Once they got behind that outer mat of reinforcing steel, the substrate was solid, showing the forming. That's the pump that we used. You notice they put the biggest guy on the end of that hose. And that's after the pumping was complete. That's showing the finish, the surface after the forms were removed. We had to do some rubbing. They had to do some rubbing and filling of those holes. And then that's application of the sealant. So the other part of this project was we put a 5-inch single mat reinforced concrete bridge deck over the adjacent box girders and upgraded the safety features and built approach slabs. 2021 best practice was awarded. This is Fabio Casillas. He actually wrote this, and I got to reading it, and I think it's a bunch of lies because he says that he purchased this vehicle, and I think he stole it from his kid, actually. But he basically mounted a GoPro camera on a remote control vehicle and had it interacting with a tablet. And that's what that looks like. He also paid for it all himself, aside probably, well, I think he paid for the remote control vehicle too. He just stole it from his son. And I know Jimmy Camp was asking about this in Phoenix, and I don't know that I ever sent it to you, Jimmy, but Vermont Agency of Transportation did a study on this very subject. So if you're interested, it's online, available online. Okay, in 2021, this structure repair crew was also awarded statewide best project. This was structures 6776 and 6777, and it was a bolt removal project, which seems simple, but it wasn't. Summary, structure 6776 and 6777 located on I-25 at mile point 106.9 over Nogal Canyon were built in 1968. Each bridge consists of 3 simple spans with rolled steel girder approach spans and steel deck truss main spans. The structures were placed on the STIP to be studied for rehabilitation or replacement after a similar structure on I-35W suddenly collapsed in Minneapolis, Minnesota in 2007. Project control number 1100980 was established, and an engineering consultant was selected to study the structures. One deliverable the consultant was tasked with was to produce an updated load rating. In April 2020, the consultant's preliminary analysis was submitted and showed alarmingly low load ratings with limited bolt shear capacity at several bolted gusset plate connections. Numerous conservative reductions were used in the consultant's load rating for unknown items such as bolt threads and shear plane, bolt condition, and bolt strength, as well as known items such as filler plates and bolt size. Therefore, it was necessary to extract bolts from the areas of concern for examination and testing. All of the bolted gusset plate connections of concern have handhole access through the steel truss box members. The challenge was getting to the handholds at the bottom cord, as the bottom cord is up to 90 feet off the ground, and the upper cord is approximately 120 feet off the ground. Also, all live loads had to be removed from the structure during bolt extraction, which we found out after some planning and coordination. So we used traffic control devices, a backhoe, large loader, compressor, generator. We tried out our Paxton Mitchell peeper to access some of these areas, our Paxton Mitchell Mark II snooper, 125-foot straight telescoping boom genie man lift with jib, and then a 150-foot man lift. 3/4 inch and 1 inch drive pneumatic impacts, various hand tools, and various fall protection gear. The project cost $34,137.84. The bulk of that, again, was in equipment. It started May 13th, 2020, and we finished in June 8th, 2021, and that includes all of the planning and coordination time. And the project with our consultant is still in study phase, and the bridge type selection report is under review. Work progress: bolts were successfully removed and replaced on the southbound structure at the east truss L9 to U8, that's specimen A, west truss L9 to L8, specimen B, and west truss U8 to L9, specimen C, on 11/17/2020. The 1 inch drive pneumatic impact wrenches would not remove the nuts, so a 1 inch drive breaker bar had to be used with a cheater pipe on the handle. We started with specimen A because it was accessible from a catwalk. Specimen A would not budge until the breaker bar was pounded with a sledgehammer while 2 workers were standing on the cheater pipe. And the guy that had that idea is back there. His name is Chewy. You can ask him about it. Sometimes he breaks stuff, I'll just say that. But he went to the trailer and he found the biggest sledgehammer that he could and solved the problem. So thank you, Chewy. So all of the specimens had similar tension and took equal effort to remove. Exposed threads were wire brushed, and penetrating oil was allowed contact time at each bolt and nut prior to removal. The 150-foot man lift would not reach the U10 joint, so it was decided to remove embankment at abutment 2 of the southbound structure to position the man lift closer to the U10 joint. And that was Steve McGuire's doing. He's the staff manager for that crew. Handhole cover plates were reinstalled at specimens A, B, and C locations on 11/18. Man lift was positioned inside the excavated abutment 2 embankment, just close enough to reach the U10 joint fully extended, and the bolt at U10 to L10 was successfully removed and replaced on 11/18, and the handhole cover plate was reinstalled. The detour was removed and traffic was placed back on I-25 at the end of the day on 11/18. Man lift was picked up on 11/20, and then Gary Kinchin's our state bridge load rating engineer. He sent an electronic message on January 12th, 2021, stating that the specimens were being sent to Wood Engineering in San Diego for testing. The test reports by Wood Engineering were generated on January 21st, 2021, and they showed favorable strength test results for each bolt. The design consultant is AECOM. They submitted their final truss analysis report on 6/8/2021, indicating improved load ratings as follows. That's as-built drawing, just showing the numbering of the joints. Basically, the U was the upper, L was lower, and they started 0 from the south end and increased to the north. This is a torque specification chart. We were that 1 1/4 inch row, so it was 1,490 foot-pounds of torque. We have what I would classify as a ginormous torque wrench that we were going to use for this, but Gary had the idea of using direct tension washers instead, so that worked out. Those are some photos of the joints that we worked on. And some photos of the equipment we attempted to use to access these locations. And so during planning and coordination, an issue came up where I got called by the patrol to look at this structure because there was basically a ramp at the north end on both structures, the southbound and the northbound. So At that time, I think the day that happened, there was a recorded temperature of 114 degrees, and the structure's movable bearings are at the north end of both the truss and the north approach span, and during that time, the joint completely closed and it sheared off the top of the back wall. So we pulled in a contractor on price agreements to do this work because our crew was on the other part of the district doing some erosion control work at the time. And they also did some erosion work through that same purchase order and kind of scared the heck out of me driving their excavator up that slope. That's a photo of the man lift that we used during planning and coordination. And then this is a photo of the man lift we used during the actual bolt removal. Those are some of the hand holes. That's a photo of the inside of the truss member. Those all look really good, actually. Those are some sheets from the traffic control plan. We put all the traffic on old US Highway 85, which is New Mexico 1 now. And I'll just cycle through these real quick. These are photos from the actual bolt removal. So that's showing specimen A, specimen B, specimen C, and then there's the removal tools that we used. Photos of the direct tension washers. And then accessing that last U10 joint, which required removing some embankment. So none of the bolts removed had threads in the shear plane. However, we measured the shear plane on specimen C and D on the bolt shank just slightly on the head side of the threads. So they kept that reduction for those specimens. Testing verified that all bolts exceeded A325 strength requirements, and so therefore the reductions for strength were removed at the joints. Revised updated load ratings by the consultant resulted in adequate load rating factors at all joints and confirmed the structures could remain in service at levels above statutory limits for weight. And that will end it. I'm a little bit over. Sorry about that, Brand.
No problem. Thank you.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.